Hydrogen gas, or H2, is a gas that contains a lot of chemical energy. If you ignite it, it will react with the oxygen in the air and release its energy by means of an explosion, and the only waste product is water. That's right, no CO2, no toxic gases, just a bit of innocent water. Now, of course, uncontrolled explosions are great fun, but how do we properly use hydrogen as a fuel to power machines and vehicles, for example? Well, in order to do that, we use a device called a fuel cell. A hydrogen fuel cell is a device that takes hydrogen and oxygen and uses those to create electricity. But how exactly does a fuel cell work? Let's find out. Right here you can see my schematic drawing of a hydrogen fuel cell. On the left side you can see there is an anode, and on the right side there is the cathode. The anode and the cathode are hollow areas in which gas can be put. So inside the anode, this is where the hydrogen gas goes, and the oxygen goes into the cathode. In between them, you'll find a catalyst, which is the green layer in this drawing, and an electrolyte. So let's see what happens when this system is turned on. So we've got hydrogen in the anode and oxygen in the cathode. Now the hydrogen inside the anode wants to go to the other side, meet up with the oxygen, and then react with it to form water. But there is a problem. It cannot get to the other side because there is something in between them. The electrolyte. The electrolyte is a material that only lets positively charged things get through it. Hydrogen is not positive. You see, hydrogen atoms consist out of one proton and one electron, one positive particle and one negative particle, which makes the overall particle neutral. So the hydrogen in our system is neutral and not positive. So it cannot get through the electrolyte. There is, however, a solution, which is the green layer in this drawing. This is the catalyst. Now what the catalyst does in this case is splitting off the electrons from the protons. So the electrons of the hydrogen atoms are removed from their protons. So now we've got a bunch of protons and electrons. The protons, also known as H+, can get right through the electrolyte because they're positive, and they can meet with the oxygen on the other side. But there is a problem. You see, these are just protons. They're not really hydrogen anymore, so they can't react with this oxygen and form water. In order to do that, the electrons that are still on the other side must be transported over to the cathode first. And clever people might have noticed that I just used the words electrons and transported. And transporting or moving electrons, there's a name for that. Electricity. That's right, moving electrons is what we call electricity. So we can simply connect a wire like this, and then the electrons will simply be able to flow right through that wire to the other side. And then they will meet up with the protons, and then they can react with the oxygen to form water, which can leave the system. And now what we've got is an electric current running through a wire, which we can then use to power a light bulb, a motor, whatever. This is the power output of the fuel cell. Now, despite the fact that the fuel cell is such a clever invention, it does have some drawbacks. First of all, it gets really hot when it's in operation, and this can lead to the fuel cell potentially damaging itself if it isn't cooled properly. Another disadvantage of a fuel cell is that it's very, very expensive. You see, remember that catalyst we talked about, the green layer? Well, that's actually made out of platinum, which is of course a very expensive material. But anyway, now you know exactly how a fuel cell works. I hope you've enjoyed this video, and of course, thank you for watching.
Methanol. Did you know that every day methanol benefits our lives? And every day you interact with products made with methanol? Methanol is an essential ingredient of modern life. It's used as a building block to produce hundreds of everyday consumer and industrial items. and is also an innovative, clean-burning alternative energy solution. A clear, colorless, biodegradable liquid, methanol is a key ingredient in the materials used to construct and insulate our homes, making them energy efficient. It's used to make the fabrics, carpets, and clothing that style our lives and the technology that keeps us connected. Methanol is also used to make automotive components lighter, making cars more energy efficient and reducing CO2 emissions. A clean-burning fuel, methanol can help improve local air quality by reducing engine emissions. It is used to fuel cars, buses, and trucks, and ships that transport people and goods around the world. Methanol is also emerging as a clean-burning fuel for power generation in remote communities, helping keep homes bright and businesses working. Today, methanol is used as a clean-burning fuel for industrial boilers in China, replacing coal-fired boilers and contributing to local air quality benefits. How is methanol made? Methanol is made of hydrogen, oxygen, and carbon. It occurs naturally in the environment and as an organic molecule is a building block of life. Methanol has even been found on newborn stars in space. Here on Earth, Methanex, the world's largest producer and supplier of methanol, with operations around the world, makes methanol by combining natural gas with steam to produce synthesis gas, which is then converted and distilled into methanol. Methanol is also made from renewable sources such as waste, biomass, and recycled carbon dioxide, providing a pathway to a clean-burning, renewable liquid transportation fuel. As a responsible care company, Methanex works to ensure methanol is handled safely during all phases of methanol production, storage, distribution, and use. Every year, billions of liters of methanol are safely produced, shipped, and distributed. And the global methanol industry generates $55 billion of economic activity in communities across the world. As global energy demand continues to grow, methanol provides an innovative, sustainable solution to our energy needs. With its multiple sources, uses, and benefits, methanol is an essential ingredient in our everyday lives and an innovative, clean-burning alternative energy solution. To learn more about methanol, visit methanex.com.
In the previous episode, we explained what hydrogen is and how it works. But for what applications can we use hydrogen? There are already many different hydrogen applications. Isn't that exciting? But first, a little bit about the two different ways in which hydrogen can be transformed into energy. In the previous video, we explained how hydrogen can power a vehicle using fuel cell technology. Here, hydrogen is combined with oxygen, which generates electricity. Another option is hydrogen combustion, where hydrogen is burned and converted into mechanical energy. In this process, nitrous oxides are released as well, having a negative impact on the environment. Both the fuel cell and combustion techniques are used in applications nowadays. The existing hydrogen applications can be split up into four main categories: industry, transport, energy balance, and heating. In the industry, hydrogen is already being used as a method to transform rough materials into semi-finished products. For example, in Sweden, a commercial steel mill has successfully used hydrogen combustion to produce the high temperatures required to create steel. Now, we can use this modern technology instead of fossil fuels to advance to a green world fueled by hydrogen. Another category is hydrogen in transportation. Even transportation can be split up into different categories once again. Transportation can be done over land, such as by road. It can also be done over water, like shipping, or in the air, by using aircraft. Each of these can be powered by hydrogen as well. Already existing examples of hydrogen propulsion can be found in, for example, the Toyota Mirai or the Hyundai Nexo. Both great hydrogen-powered cars working on fuel cell technology. And anyone can buy one. For a faster example of hydrogen propulsion, you can look at our Forza hydrogen race cars that can reach speeds exceeding 200 kilometers an hour. Another example of a fuel cell hydrogen-powered vehicle, one that is a bit more surprising perhaps, is a tractor. Yes, you heard that right. An autonomous hydrogen-powered tractor has been developed in China. The use of hydrogen as a way to fuel our transport has a huge impact on our environmental footprint. Did you know that 20% of worldwide energy use goes to the mobility sector? Imagine if all of that was powered by hydrogen. The world would be green again in no time. To continue explaining the many different applications that exist in the world of hydrogen, we will now continue to talk about energy balance, where excess energy can be stored as hydrogen and used later on. A great example of how hydrogen can power the greatest things is the Olympic Village in Japan. The entire village is powered by hydrogen. All the vehicles in the village will use fuel cell technology. Even the Olympic flame will be powered by hydrogen. Now the final category to be explained in this video is heating. Could we maybe even warm our houses using hydrogen? Researchers in England are considering it. This would be a huge step towards creating the green world that we desire. It would be a lot of work in order to replace the already existing heating systems, but the environmental impact would be astonishing. In the UK, between a quarter and a third of the gas emissions come from people warming their homes. Imagine if we could eliminate most of that. How awesome would that be? We hope you agree hydrogen has a lot of potential for the future. Want to learn more about hydrogen technology? Follow us on our social media channels and stay tuned for more explainers in the future.